Sounds straight? No? Yes? Okay. So we've seen in the previous sessions that interoperability is a key enabler of the EOS federation systems. So interoperability faces several challenges. Okay, so when we talk about planetary and societal challenges, it's even more bigger this challenge. So what is the how EOS support this cross-domain interoperability? For today, we have some speakers. So we will start this session with an introduction to the WorldFAIR project, following for one of the outcomes of this project that will be presented for ARPON. This is the cross-domain interoperability framework. Following this presentation, we will show you some use cases that we will study in the projects FAIR Impact, WorldFAIR, and EOSC Future. And finally, we will have a small discussion if we have time. If not, we will have a QA section. So I would like to invite to the first speaker, Simon Hudson, who is Executive Director of the Code Data and Coordinator of the WorldFAIR project.
Okay, thanks for the introduction. Hello, everyone. Sorry I couldn't be there in person, just wrangling screens to make sure that I can share the presentation. Hopefully you can see the slide deck there and now in presentation mode. I'll try and rattle through this quite quickly, but the purpose of this, as has been said by Esteban, is to give an introduction to the WorldFAIR project. And Esteban mentioned the context of global grand challenges. So I'm going to give a little bit of history and the background to our thinking around the WorldFAIR project and where, at least from a co-data perspective, and I think from the perspective of a number of our partners, where it came from. It is a European Commission-funded project. It's not part of the EOSC set of projects. It was funded by the WIDERA call, but it has its roots in some previous activities. CODATA is the Committee on Data of the International Science Council. We're part of that global science system, and we have strong links to the UN system as well. In 2017, we were asked to start exploring issues of cross-domain interoperability. Why was that? There's a justification and a part of our thinking, the premise for this activity on that slide. The major pressing global scientific and human issues of the 21st century can only be addressed through research that works across disciplines to understand complex systems. We have multiple examples of that, whether that's in climate change, mitigation and adaptation, whether that's in the growth of cities and understanding those complex environments, whether that's in human interaction with biodiversity or other phenomena in the natural world and disaster risk reduction. All of those research areas require an understanding of a complex Earth system in many cases, but the admixture of extra complexity of understanding the human systems and processes that interact with that. So they're wicked problems, they're interdisciplinary, and they often need transdisciplinary approaches in order to respond to those issues. We've been exploring this for a few years, as I said, starting in 2017, with a number of pilot projects in various domains, trying to understand cross-disciplinary case studies. This all led to the WorldFAIR project. We're about halfway through. It's a 2-year project funded by the European Commission. Outside of the infra-EOSC activities, as I said, but very closely linked to it. And we hope that what we're doing in WorldFAIR will feed back into thinking in the European Open Science Cloud. Something that was really important about the call for projects in this particular call is that we were allowed to have beneficiaries outside the European Union. So we have a number of partners and beneficiaries in Australia, Brazil, Kenya, New Zealand, and the US who are actually beneficiaries of the project. That was really important because it allowed us to engage with a number of authoritative international entities which make decisions with community support about the specifications and standards, and those decisions are likely to lead to the implementation of those standards and specifications, and to ultimately to cross-domain interoperability through that process with an admixture of engagement, negotiation, and governance. It's also, I should stress, an important partnership between CODATA and the Research Data Alliance. CODATA is the coordinator. Here are the partners, and we're very grateful to have them on board in the WorldFAIR project. We see ourselves very much as responding to this recommendation from Turning FAIR into Reality, this call to enable research groups, research disciplines, I should say, to develop interoperability frameworks. And we gave in that report a definition of what we meant by an interoperability framework, which is on that slide. But really importantly, to support interdisciplinary research, which I've already mentioned, these frameworks, these interoperability frameworks, should be articulated in common ways and adopt global standards where relevant. That should be pretty obvious, but it's really important. And that's a mission we see ourselves as responding to. I mentioned that it was a case study oriented activity and that we had developed some of the case studies beforehand. This petal diagram was included in the proposal and in the project plan and became our logo, and it tries to communicate the diversity of the case studies that we work with, the incredible ambition of having as many as 11 case studies from a whole range of different research areas. We try to mitigate that complexity by clustering the case studies. So there's 3 relating to chemistry or materials in one way or another in red, 3 relating to social sciences and health, 2 relating to biodiversity, and there's a biodiversity webinar earlier today, which some of you may have seen, or please check out the recording afterwards. Ocean sciences and disaster risk reduction, looking at the environmental side, and cultural heritage. In the center of that is a coordinating activity which is led by CODATA, and the primary objective of that coordinating activity is to develop a cross-domain interoperability framework. WorldFAIR has developed and is implementing a methodology. We've been using the FIPS approach, which is a methodology developed by the WorldFAIR initiative. It's a questionnaire, a set of questions around how do you and how does your community implement FAIR for each of the principles. It's supported by an online tool. Subsequently, with each of the case studies, we've held a CDIF workshop, a cross-domain interoperability framework workshop, to try and understand their approach to interoperability, the requirements in that particular research domain. And then the ultimate outputs for each of the case studies will be a set of recommendations, an implementation plan, a second set of FAIR implementation profiles with a more aspirational approach, and of course the cross-domain interoperability framework. This slide I'm not going to spend a lot of time on, but it's there as reference for some of our outputs. If you want to know more about how WorldFAIR has used FAIR implementation profiles, there's a report there, deliverable 2.1, that came out towards the end of last year. There's a policy brief which presents some of our thinking about what's required at a global scale as well as at an EOSC scale, genuinely to realize cross-domain interoperability. And there was a webinar from late June where we discussed both our work on FIPS and the cross-domain interoperability framework. If you're interested, we're coming up to an intense period of work at the Dagstuhl venue in October, and there's some information about that there. I'm going to hand over now to Arifan Gregory, who's going to talk about the cross-domain interoperability framework. This slide really details again that process and methodology, and also stresses that we see WorldFAIR as one stage in an ongoing process of developing a cross-domain interoperability framework, of working with a set of case studies, and genuinely doing this on a global scale, which I think is really important for science and research generally, of course, but also for EOSC, that EOSC should not just be a European initiative, but should be open to the world. And so we're in conversation with a number of organizations to identify additional case studies as we go forward beyond the project, and we already have funding from our parent body, the International Science Council, for additional case studies on earthquake data and on flooding cholera as cascading hazards. And that's my last slide. Thank you for your attention. I'll hand over to Arafan.
Thank you, Simon. So I would like to invite Arafan. He's going to talk about the cross-domain interoperability framework, and I would like to ask you to stick to the time. Okay? Yeah, this one. Yeah.
Hello. Oh, there we go. Does that work? Yes, I think that's right. Is that right? Yes, that's my first slide. I want to talk a little bit in a general sense about, I'm not getting the horrible echo, am I? No. Thank you. A little bit in a general sense about the challenge that you face when you're looking at actual cross-domain use of data, because there are some differences, I think, between traditional use of data and the documentation, the metadata that you have within a domain and across domains. Something that we've clearly seen in a lot of the presentations today is that there are a lot of standards. And every domain, you're not talking about a single standard, you're talking about a suite of standards, and often more than one based on the infrastructure that you're interacting with or the subdomain that you happen to be in. There are a lot of standards out there, which sort of defeats the purpose when you think about it. But there's also a good reason for that, because domains are different. Everyone's special. We know this. So you see a lot of transformations. And if you were in the last session, you saw quite an interesting presentation of the sort of things that happen in shock, for instance. Lots and lots of transformations between different standards in order to be able to reuse data coming from different sources. Sometimes those transformations can be automated to some extent, but sometimes they can't. When you're looking at mapping a domain ontology into a different domain, you're dealing with a situation where there's almost a hard requirement for human interaction and intelligence. And even based on differences in the research question being explored, the mappings may change. So very often, there's a human component in that, but it's almost always the case that you could better support transformations with some sort of automated functionality. Something that we've learned a lot in WorldFAIR and in some related projects is that the granularity of metadata needs to be sufficient. Very often you see metadata being cataloged metadata at the level of a data set. That's not sufficient for cross-domain use in many cases. Rich, granular metadata at what we term the variable level, at the level of observations, turns out to be incredibly important, because very often you're doing transformations of the data at a much more fine-grained level. You can't simply take a data set and know what it is. And something else that's become very clear is that the context within which data is produced becomes very important for its reuse. Within a domain, people are familiar with the literature, with the sources of data, with the processes for collecting it. When you start crossing domain boundaries, that knowledge, that implicit knowledge, breaks down. And so we don't just see a demand for more granular metadata in cross-domain scenarios. We also see a demand for more contextual information. And you'll be seeing some use cases that sort of address that. Here's the basic problem. I just saw the EOSC Interoperability framework, which is a cool framework, and it's a great way to automate this picture. Every domain has 1 million standards, and we're going to let them all put them in a registry and then talk about and describe the resources. And most of the FAIR approaches to this problem are similar. This is an issue, because that will not scale, okay? And that is the fundamental realization behind CDIF. We need to move to something where the problem is made more tractable by having cross-domain formats that are agreed. And people say, oh, you can't do that, that's impossible. And yet, there are infrastructures where this works at fairly large scale. So the idea that we have is, let's take this mass of transformations and reduce it in size. It's still going to be a lot of transformation across domains, but it could be made a lot simpler by having a sort of hub format that allows metadata to be put into a common format and then mapped out to another domain format. This has the other interesting impact of pushing the work of doing that transformation onto the producers rather than the users. And when you think about that, that is a big part of simplifying this problem. So we put that up. It's sort of an obvious slide, but it's something I think that gets missed a lot. In WorldFAIR, we're really looking at taking a first stab at defining that core format, that lingua franca, if you will. And Simon mentioned the turning FAIR into reality. When we talk about a framework, this is a little different than the EOSC interoperability framework in that we're really trying to define specifically the profile of metadata standards that we can use to interoperate. And that's very different than producing a framework within which people can talk about those standards. So you can think about CDIF as a set of the profiles that would be entered into something like the EOSC interoperability framework and registered for cross-domain use. So I think there's a pretty nice kind of alignment between these things. The idea is that WorldFAIR will produce a first draft of this, and that will come out early next summer, and that the work will continue beyond that point. We don't see CDIF as something that ends with the first stage of the WorldFAIR project. The major inputs are the WorldFAIR case studies. We have convened a group of about 30 experts, half of whom meet on a bi-weekly basis to produce the draft. That's our working group. And then there are a lot of other related activities, like work in EOSC Future, the EOSC Interoperability Framework, some of the work going on in FAIR Impact, and so on. So we're trying to be very broad in how we connect this work. What is CDIF and what isn't it? Well, it is a set of guidance for implementers. That is essentially cookbook guidance for people writing code, saying, when you're going to support this function, here's what you should do. Now, that seems very bloody-minded and literal, but the idea is that unless you give people very, very clear instructions about how to encode metadata about their resources, you actually won't get machine-to-machine interoperability. And that's something people don't like to deal with, that fact, because it's very complicated and difficult, but machines cannot generalize. And we need to have an agreed way of implementing the metadata about our resources. And so the idea is to provide guidance on that as a reference for people, and to do that in a very, very clear way. Essentially, what CDIF is going to consist of, and what we've been working on, is a coordinated set of metadata profiles based on existing cross-domain standards. And the idea is that some of these would be about services, but primarily about the resources that are used, data and related metadata, around functions identified as FAIR supporting functions. And I'll talk about that a little bit more in a minute. The idea is that this is based on reality, on existing technology approaches and existing standards. It is not a cool new academic exercise about technology that doesn't exist yet. There's a lot of research going into FAIR, and that's great, but it's not implementable today. And that's a big challenge if what we're trying to do is to encourage people to actually interoperate in the modern world. So we're trying to keep CDIF to be a progressive thing where the barriers to entry are low and that the technology and the standards are familiar as much as possible. So the idea is to provide guidance around familiar things that people adopt more easily. And that's not an approach that all of the standards in the FAIR space are taking. This is a quick snapshot of the functions that we see as constituting FAIR. FAIR is a set of principles. It is not an implementation guideline. It is not a roadmap to do anything. You have to say, what are the functions we're going to support? What are the business activities? How are we going to implement that at the services level? And what standards will we use for those services to communicate? And so the idea here is that we've identified some basic functionality and are looking at standards that will enable that functionality. As Simon said, we're really focused on the area of data integration and assessment, determining that data is fit for purpose and fit for audience, because that's the biggest challenge here. We're pretty good at discovering data. Access is maybe a little bit lighter in terms of automation, but data integration can be heavily automated given rich enough metadata. And that's probably the main focus of CDIF at this point. Something we don't like to forget is that you have to connect the business of research to the data. That if we're spending a lot of money interoperating, the question will be raised, why? What is the return on investment? What is the actual benefit? And if we can't measure impact at an academic level, at a policy level, then it's very hard to answer those questions. And so we're also looking at that, although that's maybe not the highest priority within CDIF. You're going to be seeing a project coming out of EOSC Future in a little bit, climate neutral and smart cities. And this is a great example of the challenges that you face when you're doing cross-domain research. And one of the standards that this is based on are one of the standards we're looking at in CDIF. The idea here is that you have social scientists having to work with unfamiliar sensor data about the climate and the environment. And how do you bring that together and present it to a social scientist so that they can understand that data, trust the data, and work with it effectively? I'm not going to steal Akim's thunder. He's going to talk more about this. But we've learned some very interesting things in this kind of project, and you'll be hearing about a bunch of them, actually, today. The pattern of cross-domain data use looks very often at a primary set of data and then other secondary sources that provide context. And that's a little different than the way data is traditionally used within domains. And it demands other kinds of metadata. What we're seeing is that having background about data that is made integratable, you have to explain the processing and the methods very thoroughly. And that's sort of one of the things that we're learning and that CDIF is trying to address. Ultimately, you can't solve these problems with technology or with metadata standards. You can only solve these problems through scientific collaboration. But the standards and the metadata and the technology has to support that collaboration. CDIF is laying a sort of foundation on which that kind of support can be built. And I think it's important to understand that it's a complicated process, but that ultimately access to somebody else's resources doesn't explain what they are or how to use them, and that has to be done through scientific collaboration. What we need to do as technologists is try to support that, and that's at the level of standards and the frameworks and services. But it's important, I think, to remember that there's an entire gamut of things there. And so CDIF is sort of an attempt to start that process and to answer the hard questions about data integration and really interoperability at the level of data and the level of the science demands. So I think over to you, Akim.
Thank you. So our next speaker is Joachim.
No. There you go. Okay. No. We had it for a second. Yeah. Okay. Okay, this is about EOSC Future project, climate neutral and smart cities. And yeah, the purpose is to provide integrated data to the social science researcher. This is about the integration of climate data and air quality data with primary data from the European Social Survey. The ESS is a biannual survey in Europe in 32 countries, and it's very established. And it includes also questions on attitudes toward climate change. And therefore, it's interesting to combine that with hard science data. But there are a couple of issues, no? And there are increased metadata requirements for the cross-domain use case. Already, with a reuse of data within one domain, especially if data combination, data transformation is involved, you need a lot of detailed information, a good documentation which is not only available for the primary researcher, but for the secondary use. And with a cross-domain data integration use case, this is different. There is an increased requirement on metadata, especially, I think, for two reasons. One is a researcher is usually only familiar with one domain, so the person needs more information for the data from the other domain. And also there are challenges in the integration of data from multiple domains. One example here is the spatial region. The social sciences are using a geographical classification system called NUTS for defining spatial areas. The hard sciences are using grid representations of that. And the NUTS classification is based on administrative borders and areas. So I'm saying here some computation is necessary and increased documentation of this documentation is necessary. We focused, therefore, very much on the provenance information, and the following slides show some screenshots of an application we developed to show the interested researcher all this detailed information. This shows just an overview. All the blue boxes represent activities. And there's a hierarchy. From left to right, it goes deep into the activities. Here is one of the higher level activities. It's about the data processing of the ERA 5, the climate data. There's always some description available, and on the button you see subsequent lower level steps. One of these steps is to create a variable like the one which calculates total precipitation by date in millimeter for each grid cell, things like that. The step is the blue box in the center, and the yellow boxes are the input variables. And the purple one is the created variable, which is then reused again of subsequent steps represented by the blue boxes, the small ones on the right-hand side. One of the subsequent steps creates another variable. And on all these views, on all these screens, the user can also click on here the red circle, the script. It goes to the code which generates the variable. So the user can really see what happened. And clicking on one of the input or output variables goes to detailed information in the data repository, here also combined with a diagram. What is the underlying information which needs such application? We used here the DDI-CDI, that's the DDI cross-domain integration specification. It's an emerging standard for the domain-independent description of data. And DDI process description is a part of that, which is aligned with BROF ontology of the W3C and also with BPMN of the object management group. That's it. If you're interested to get further information on the project or to try this tool, it's online available from this website, the ESS Labs. Thank you.
Perfect timing. Thank you. So our next speaker is Pierluigi. He's from the WorldFAIR project, and he's going to speak about cases of study of ocean. So Pierluigi, he's on Zoom.
Yep, just a moment, just setting up the sharing. I think let me know when you can see the slides, please. I'm assuming the audio is okay. Is the audio okay? I can't hear you, but I'm assuming you can hear me. Alex, can you hear me? Alexander?
Audio is fine on Zoom. I don't know about in the room, though, but I assume that's
Okay, well, we'll assume that they can hear me, and if they can't, well, they can protest. But I'll start. Okay, so this is a case study about the oceans, and this is a really nice collaboration and a sort of cross-link between the WorldFAIR project from the European level with the ODIS, or the Ocean Data and Information System project, funded by the Government of Flanders Kingdom of Belgium, but executed by the IODE of UNESCO, so for International Oceanographic Data and Information Exchange. Very similar goals. We have to build federated systems to share data. And so this is just a briefing on what we're doing there. So I'm from the Alfred Wegener Institute, but some of my time is given to IOC of UNESCO to lead the implementation of this project for on behalf of the member states and of course all associated organizations. So jumping right in. So the mission is to create for the world, essentially, a first order data and information system to share information about who has what in terms of capacity, services, data sets, projects, etc., and construct the foundation of a digital ecosystem that will progressively be enriched and deepened as things go by. So the main thing is that we're connecting very independent systems with very sort of stable cultures. They know their system very well. You can't tell the Pacific to manage the way that the Latin Americans do, or the Caribbean does, or Europe does, but we have to make them talk to each other. So again, very similar to the WorldFAIR logic, to improve discovery so that people know who's doing what in the ocean for sustainable development, but also for science. And that's across public, private sector, and governments, of course. And to actually figure out how to get all of these different thematic and regional nodes stably interlinked. So when this project is over, the whole thing doesn't just disappear, right? So that has to be a change of culture, and this is why it's quite appropriate in UNESCO. And of course, that in some areas we have to provide capacity development and capacity building to actually support the connection to such a system in a sustained way. So all of that is aligned to some of the high-level implementation plans and data and information strategies coming out of the UN Ocean Decade of Science for Sustainable Development. We are now preparing the implementation plan after the strategy plan, which will go into some more details, and again is aligned quite strongly with some of the core principles of CDIF and also of WorldFAIR. It's important that we have that strategic to implementation alignment so that, again, through multiple layers, we're building the same kind of digital ecosystem, and it's not just a question of buzzwords that don't actually lead to implementation. Our initial areas, and our funder and also the IOC was very keen on this. We had to make sure that this worked in areas where there are highly variable capacities, some very mature data centers and some very sort of basic capacities to participate, but they had to be all interoperable so that we leave nobody behind. And so we did that. We put together a consortium that has been growing and growing. We overachieved by about an order of magnitude in the sense of who we federated, and more are actually coming on board as this time goes. So again, they're plugged in, they're all independent, and they're projecting out their metadata in ways that they can all understand and actually start to map things to understand who's doing similar things, how can they align, and how can they actually sort of elevate the entire global system, with IODE being the neutral United Nations entity in the middle that has, again, that regionally neutral perspective to usher those conversations through and through. It's really key because everybody's going to go to their familiar data source when they have a question. And those data sources have to be able to federate out those queries to different data sources, very, very separate from them, and assemble a response. The world is too complicated for people to start having these one-stop shops. These don't really exist without some kind of global supply chain of data and information. And that's our objective. So again, from Terry McConnell, similar thinking. Everybody wants that great dashboard, that great sort of wonderful sparkly fountain, but we have to build the plumbing first. And that's been our sort of motto. We took that from Terry's intervention at the Digital Twins of the Ocean Summit in the UK. The next one's in China. And we're taking that to heart. So let's get the plumbing, even if it's basic, let's get that in order first. So that's the plumbing of it. It has to be sustainable, that even though it doesn't depend on the project, the nodes should be sovereign in the sense they can do what they want. You don't need or depend on a central hub because the web itself will function as your hub, again, using linked open data practices, the original conception of the web, to make sure that you can federate all of these partners. And then you let the partners have control over that, because if policies change locally, if their indicators or their data sovereignty regulations change, they should be able to turn on and off their data sharing as they need without having to consult or go through a heavy process. So that lightweight system is really, really key for the first order. So it's all just linked data. I'm sure this audience doesn't need much more on that, but one of the main things is to bridge all of these UN systems, also reporting on the SDGs, on the essential ocean variables and others, to infrastructures within regions, individual research groups, etc. It should be open, and everyone can source from that linked data universe to create their own hubs, so they don't necessarily depend on what IODE or anyone else creates. We have a first order interface. It's just a simple search engine where you can search through those thematic types, like who has expertise, where are the projects, where are the data sets, who has spatial data. And you'll get the results that are coming from all of that federation. Again, it's not centralized, it's indexed in the knowledge graph, and then we update that every week or every day, depending on the partner. We can also put that information on a map. So finally, this should have been done a long time ago in some senses, a researcher can go to a certain region and say, who has any kind of ocean data about this region, regardless of where it comes from, and the system links back to them and their services and we trust that they know their data better than anyone else. So we have a dashboard to actually check that these things are working all the time. So it's not just FAIR in kinds of documents or reports. We're checking all the time that all of these partners are plugged in. Reports are generated if there's a problem. And we can fix those problems and also monitor the evolution of the graph as we add more partners to the federation. That's really key because, again, we hear a lot about interoperability in practice. I mean, having an ontology does not make you interoperable. You have to show that it's interoperating, and this is helping the global conversation about cross-domain interoperability. The ocean itself is a cross-domain space. So those are the core profiles. The main point here is that we're just using schema.org and JSON-LD. Again, vanilla stuff that you can hire any developer off the street to be able to work with. And we're kind of cleaning up the usage for ocean partners. So again, that helps us build these graphs. But when people come along from our various regions, for example, Africa, or if you have a hazards and disasters use case like we do in WorldFAIR, or somebody wants information for protected areas, we help them get that into that established standard as Arifan has described. So we don't sort of duplicate things or make things weird. We nest domain-specific stuff within a generic format. And this will help us with essential ocean variables, essential climate variables, etc. I'm just out of the Goose BioEco panel meeting where we're thinking of implementing this, or we have a pathway to implement this. This is again key because that Otis interoperability layer is bridging some of the other programs in the UN Ocean Decade, like the biomolecular monitoring program and the digital twinning of the ocean program. That's figuring out how to share their blocks, their services, their data sets, etc. In WorldFAIR, it's already been briefed, but we have a deliverable out, which you can access. I'll dump some links in the chat. I don't know if you can access that, but you can find this certainly around on the WorldFAIR website, where we've actually broken that down, given a bit of a technical report on that, and also a strategic report, where we identify priority areas of building cross-domain interoperability according to the IOC priorities, but also the other communities. The key thing about that is creating a domain-neutral form of what we did with Otis, because there's nothing here that limits it to the ocean. So through CDIF and through WorldFAIR, we're going to generalize that, shift the governance of that to a broader community so that we have, again, an integration point for at least search and discovery with some semantic control, light semantic control, into which you can embed disciplinary specific controls. It's all doable. And that's a big goal because we're talking to the WMO, we're talking to other UN agencies, the International Seabed Authority for Biodiversity, to figure out how to actually bridge these big data systems that are out there. So
we are running out of time,
we all have this vision, right? But we've all realized it's a lot harder to do in practice without.
Yeah, we are running out of time, so you have 1 or 2 extra minutes.
That's it. I'm leaving with this. Sorry, but the whole point is.
No, you can continue. 1 minute.
1 minute. Okay. So I'll just leave you with these sort of points up here, because in the digital ecosystem engineering, it's a socio-technical system. The technical stuff is relatively easy to build stuff. Again, as Arifan said, we're not dealing with the cutting-edge innovation. We just have to do the plumbing to get people on the same page so we can all develop together. The hard part is building those agreements and governance models that people will actually buy into. With Otis, it took us quite an effort. But again, it was at the IOC Assembly. The member states have supported it. So we're getting, again, that whole cross-stakeholder awareness that such a thing is needed. And they're excited because all of the regions can participate. It's not something that only the Europeans or the Americans can do because of their funding, the US Americans or the Canadians. It's approachable. And that gives us that basis upon which we can formulate strategic documents and implementation guides that are compatible with CDIF in the future. And I'll stop there. Thanks.
So our next speaker is Alexander for the WorldFAIR project. So Alexander is online.
Yes, can you hear me?
Yeah, perfect.
And can you see the screen? Yeah.
Not for the moment. I would like to ask you to stick to the time. Thank you. Yeah.
Can you see the screen now? Yeah.
Yes, perfect.
Okay, thanks. Great. So yes, I'm Alexander Prent. I lead the geochemistry work package in the WorldFAIR project on behalf of OSCOPE and the One Geochemistry Board. And I'll talk today a little bit about geochemistry as an example for cross-domain interoperability by looking at the domain of geochemistry in itself, how it can be an example so complex that it could be looked at as domain interoperability, and how that relates to cross-domain operability as an example. So it's such a complex community, really, that produces highly specific data, and there's many subdisciplines. And even these disciplines, they can produce such data that other disciplines within the domain do not understand or particularly easily work with. So, for example, you get, you have your rock and you analyze some chemistry of that, and you can get your elements, and then you analyze it a bit further, or a different group analyze it, and you get these three types, and they can be in themselves can be enough for a research paper or research outcome. But some disciplines would not necessarily need these types of data, and so they don't understand those data. Now we looked at within the work package there, we looked at that within some repositories and data collections. There's many of these data collectors and repositories out there, and they can be generalists, storing PDFs and zip files of the data sets, or they can be super specialists where they store only data from astromaterials, meteorites and such. And there's repositories within or in between, storing, for example, data from ocean rocks or land rocks in DGIS and EarthChem. And these repositories, they are so specialized that they may be FAIR in themselves, as in FAIR in the repository itself, but not in between repositories. So they have this specific data, which can be looked at as a subdomain in themselves, and they do not speak together. So we look at this in the One Geochemistry or the geochemistry work package. How can they become more interoperable or more FAIR between the repositories or data aggregations? As you all know, that FAIR is much more than just the FA, I, and R. It's based on these 15 principles. You can look at how FAIR a repository is by asking the FAIR implementation profile questions and applying the questionnaire. Now we've had 2 repositories do this between themselves, or 3, and they looked at they filled out these FIPs, and they came to the conclusion that one of the easiest things to do was to come together and talk about a vocabulary, have a structured vocabulary that is the same or mapped, by which they can communicate between the 2 repositories. So for the geochemistry community, the FIPs are a very useful tool to use and identify which FAIR enabling resources need to be created to become more FAIR as a community. Now, one of the outcomes of that project is that we should have FIPs for each of the repositories, and by comparing these FIPs, FAIR implementation profiles, there will be clarity on what FAIR enabling resources are missing and need to be developed, and what crosswalks should be developed between existing FAIR enabling resources. So within that, you could, these FAIR enabling FAIR implementation profiles, once also published, it enables also other subdisciplines to tailor their FAIR enabling resources or map and develop crosswalks that furthers the discipline and the interdisciplinary domain interoperability. So I'll stop with that. Thanks.
Thank you. So our next presenter is Nicola Fiore. He's from the Fair Impact Project. So Nicola, sorry, but you only have 5 minutes. Go ahead.
Hello, can you hear me? Okay. Good afternoon. I'm Nicola Fiore. I'm the ICT Service Center Coordinator of LifeWatch ERIC. Today I will introduce which is the semantic approach of LifeWatch, and in particular the semantic platform. LifeWatch is the European infrastructure supplying e-science research facility to scientists, similar to the chemistry. We have different in the biodiversity and ecosystem domain. We have different and very heterogeneous data provider. We can talk about different domains in the domain. So one of the goals of LifeWatch is to federate this distributed center, observatories, and research institutional environment management centers, adding knowledge and producing new knowledge to the researcher and to all the LifeWatch stakeholders. We would like to build a unique, single, accessible web space to all the knowledge. So LifeWatch should be like an umbrella. To do this, we are building a very complex platform. You can see here in the picture a very high-level architecture overview, where in the left you can see on the bottom the different data providers that could be heterogeneous. This means that they can expose the data and the metadata in different ways with different schemas. So they can use exposer or APIs or service. We should be able to collect data also outside the LifeWatch network from the external data facilities. One example is GBIF for us, that is an entity external to LifeWatch. All the harvested data are annotated and managed by the semantic platform. That is a very complex tool that is composed by a marketplace of semantic artifacts, different ontologies and thesauri that could be managed by a semantic editor, so extended and managed by the community. With the semantic annotator, we are able to annotate the data to make them available to the final user using a visual semantic search. I will show you in the next slide how we can do this. In the right part of the architecture, there are all the tools that can use this information. So we have the virtual research environment, for example, to analyze in different way using semantic or with the traditional algorithms. They can offer services and tools to the researcher in order to analyze data and produce new knowledge. So we have a first important tool for us in the semantic architecture that is EcoPortal. EcoPortal is the repository of semantic artifacts for ecology and related domains. Actually, we have 25 semantic artifacts published, but we are working to publicate more than 100 semantic artifact resources in the semantic field. For this, we are part of the Interoperability Alliance that group all the research institutes that adopted the same technology. EcoPortal is based on bioportal technology. We are working in the Interoperability Alliance in order to make all the semantic artifacts interoperable in the different domains. Another important tool is the metadata catalog. We are able to expose and to harvest in our catalog different kind of research objects like virtual research environments, datasets, services, and workflow. We adopted a customized ISO 19139 standard profile standard for virtual research environment services, workflow, and research sites. For the dataset, we adopted a profile of EML 2.2.0 that is one of the largest standards adopted in the biological domain. So in the metadata catalog, it's possible to discover different kinds of resources that are under the LifeWatch umbrella. A tool to demonstrate the interoperability of the semantic artifact is the visual semantic search. Is a prototype that is online that make available all the knowledge of LifeWatch and has been built using a common upper ontology that is named Lupo. That is an upper ontology that describes all the digital objects that we can manage by the LifeWatch infrastructure. These ontologies combined with the metadata that are in the LifeWatch dataset, data portal, and also in with the objects that are the observation of the LifeWatch Italy dataset. So the user in the virtual semantic search can compose visually using the semantic artifact classes like observation, types, and so on, can compose the query that he would like to run. He can obtain, so he can easily formulate the questions.
Hi, Nicola. We are running out of time, so you have 1 minute extra to finalize.
Yeah, I just finished.
Sorry.
Okay, no, don't worry. So in this way, the user can compose in a visual way the structured query. There is the possibility also for the advanced user to build more complex queries, but it's a easily way to implement the interoperability of the data, of the contents, and also of the semantic artifact between different domains. I just finished, so if you have questions, so you can write to me or...
Thank you. So I think we have spent 5 minutes for questions. So is there any question in the room? No? You want to go to dinner? No question. Everything is clear. Yeah.
For the CDIF framework, it's interesting that it is not yet another standard because you mentioned that there is a lot of these. But how scalable is it? I mean, when the new standards are growing and you are developing new functions to convert between these, how scalable is this framework?
I think it's quite scalable, and I base that on the presentation that you saw from Pierluigi. For instance, the find function is using a subset of schema.org, sort of a core set of fields, and people will use different sets of fields, but the Otis work shows, I think, that you can get quite a scalable solution for that specific function. At the end of the day, it's not an architecture, right? It's just a way of embedding metadata in the resources and describing them in what are effectively websites, right? So I think the scalability is not dependent on the encoding of the metadata, right? The information is there. The systems that will operate on that metadata are the things that need to scale. So I think that you want to make it a lightweight layer that people can expose and that can be harvested. Now, that said, we're looking very hard at large-scale data harvesting for that function because we want to make things that are usable and proven to be usable from harvesters that are scraping, millions of websites. So I think, to the extent possible, it should scale pretty well. We're trying to base that on reality and not on theoretical sort of thinking.
So in principle, you are able to adapt or adopt any type of dictionaries. It doesn't matter what OWL schemas they are following, so you don't.
Oh, no. We're dictating specific schemas.
Okay. Yeah.
For the core set of fields, we're dictating exactly what people do because otherwise you don't get that minimum interoperability. Beyond that, you can begin to negotiate it. So we're trying to accommodate both things, but I think we're trying to be pretty bloody-minded and say, do these few simple things, and then we'll all be talking the same language. So.
Thank you. I think there is another question.
It's not so much a question, it's more thinking aloud. Thank you very much for your presentation, and I in particular appreciate your search for what you call the lingua franca. I was already in the webinar WorldFAIR organized, and I enjoyed it very much, and the more I hear it, the more I think, yeah, that's the way we should go. On the other side, I think, I understand that you wanted to go for something tangible and that you wanted to go for something where the implementers actually have a kind of a skeleton they can go for, yeah? But in the wider discourse about across domains, there is on a much more generic level, there's almost like a junction already. And that's just what I feel from the little practices I have been acquainted. So if you talk about interoperability from a point of view of documentation, let's say from a library point of view, traditionally, you think about it differently than if you think about interoperability in terms of a research project. And at the end, they might converge, because at the end, what they need to produce is very similar. But it's almost like which door you enter determines the practices you go. And I'm wondering if we can kind of together create a pathfinder which says to people, if you have this time, this kind of problem in thinking about interoperability, then go in this direction and look to those kind of guidelines and to those kind of projects. And if you have this kind of interoperability question, then go in this direction. I'm not sure if this is feasible, but I think it would help a lot of people. So if you think about interoperability from a research point of view, there is actually no interoperability. If you wanted to do new research and you do something interoperable, you don't do new research. Yeah? So you have to fight against the borders. On the other side, you cannot do new research without any sources. So yes, you also are operating inside of the borders. But this is fundamentally different from if you look at it from the documentation side. And what I think is often those two kind of perspectives gets mixed up. Yeah? So and WorldFAIR has done such a good job in kind of clarifying or trying to find a language to clarify the directions, the general kind of directions, these general stakeholders you work with. I'm also part of the task for semantic interoperability, so maybe there lies something we could reflect about, and maybe it doesn't have to be very complex, but I think the more Pathfinder we bring into the world, maybe the more helpful it could be.
Would you like to comment something?
As a librarian and documentation person, I really like what we're doing. I'm not a scientist, and I think what you say is true. It all comes down to how we define interoperability, and I think it's important to be very clear about that. I don't really have more of a response to you than that, except that I think you're right. I think we need to be very, very clear about whether it's the sources that we're describing and interoperating on, or whether it's something more complicated, more at the scientific level. Both are important, obviously, but. Anyone else want to?
So I would like to thank to all the speakers. Thank you. Just a small reminder, if you want to contribute or collaborate, there is a lot of EOS projects like WorldFAIR, EOSC Future, FAIR Impact. In fact, in FAIR Impact, we have an open call. So you are very welcome. And also, there are 2 specific task forces about interoperability. So you are more than welcome. Thank you.